let me ask you, I mean, there's a million ways to ask this question. I'm sure I'll ask it about habitable worlds. Let's just go to our own solar system. What can we learn about the planets and moons in our solar system that might contain life, whether it's Mars or some of the moons of Jupiter and Saturn? What kind of characteristics, because you said it might not need to be Earth-like, what kind of characteristics might we be looking for?
When we look for life, it's hard to define even what life is, but we can maybe do a better job in defining the sorts of things that life does. And that provides some aspects to some avenue for looking for them. Classically, conventionally, I think we thought the way to look for life was to look for oxygen. Oxygen is a byproduct of photosynthesis on this planet. We didn't always have it. Certainly, if you go back to the Archean period, there was, you have this period called the Great Oxidation Event, where the Earth floods with oxygen for the first time and starts to saturate the oceans and then into the atmosphere. And so that oxygen, if we detect it on another planet, whether it be Mars, Venus, or an exoplanet, whatever it is, that was long thought to be evidence for something doing photosynthesis. Because if you took away all the plant life on the Earth, the oxygen wouldn't just hang around here. It's a highly reactive molecule. It would oxidize things. And so within about 1 million years, you would probably lose all the oxygen on planet Earth. So that was conventionally how we thought we could look for life. And then we started to realize that it's not so simple, because there might be other things that life does apart from photosynthesis. Certainly the vast majority of the Earth's history had no oxygen, and yet there was living things on it. So that doesn't seem like a complete test. And secondly, could there be other things that produce oxygen besides from life? A growing concern has been these false positives in biosignature work. And so one example of that would be photolysis that happens in the atmosphere. When ultraviolet light hits the upper atmosphere, it can break up water vapor. The hydrogen splits off to the oxygen. The hydrogen is a much lighter atomic species, and so it can actually escape certainly planets like the Earth's gravity. That's why we don't have any hydrogen or very little helium. And so that leaves you with the oxygen, which then oxidizes the surface. And so there could be a residual oxygen signature just due to this photolysis process. So we've been trying to generalize, and certainly in recent years, there's been other suggestions of things we could look for in the solar system and beyond. Nitrous oxide, basically laughing gas, is a product of microbes. That's something that we're starting to get more interest in looking for. Methane gas in combination with other gases can be an important biosignature. Phosphine as well, and phosphine is particularly relevant to the solar system because there was a lot of interest for Venus recently. You may have heard that there was a claim of a biosignature in Venus's atmosphere. I think it was like 2 years ago now. And the judge and jury are still out on that. There was a very provocative claim and signature of a phosphine-like spectral absorption. But it could have also have been some other molecule, in particular, sulfur dioxide, which is not a biosignature.
So this is a detection of a gas in the atmosphere of Venus. And it might be controversial on several dimensions. So one, how to interpret that. 2, is this the right gas? And 3, is this even the right detection? Is there an error in the detection?
Yeah. I mean, how much do we believe the detection in the first place? If you do believe it, does that necessarily mean there's life there? And what gives? How can you have life in Venus's atmosphere in the first place? Because that's been seen as like a hellhole place for imagining life. But I guess the counter to that has been that, okay, yes, the surface is a horrendous place to imagine life thriving. But as you go up in altitude, the very dense atmosphere means that there is a cloud layer where the temperature and the pressure become actually fairly similar to the surface of the Earth. And so maybe there are microbes stirring around in the clouds which are producing phosphine. Mm-hmm. At the moment, this is fascinating. It's got a lot of us reinvigorated about the prospects of going back to Venus and doing another mission there. In fact, there's now 2 NASA missions, Veritas and Da Vinci, which are going to be going back and before 2030 or the 2030s. And then we have a European mission, I think, that's slated now, and even a Chinese mission might be coming along the way as well. So we might have multiple missions going to Venus, which has long been overlooked. I mean, apart from the Soviets, there really has been very little in the way of exploration of Venus, certainly as compared to Mars. Mars has enjoyed most of the activity from NASA's rovers and surveys. And Mars is certainly fascinating. There's this signature of methane that has been seen there before. Again, the discussion is whether that methane is a product of biology, which is possible. Certainly that happens on the Earth, or whether it's some geological process that we are yet to fully understand. It could be, for example, a reservoir of methane that's trapped under the surface and is leaking out seasonally.
So the nice thing about Venus is if there's a giant living civilization there, it'll be airborne, so you can just fly through and collect samples.
Yeah.
With Mars and moons of Saturn and Jupiter, you're gonna have to dig under to find the civilizations,
Right.
dead or living.
Right. And so, yeah, maybe it's easier then for Venus, because certainly you can imagine just a balloon floating through the atmosphere, or a drone or something that would have the capability of just scooping up and sampling. To dig under the surface of Mars is maybe feasible-ish with, especially with something like Starship that could launch, a huge digger basically to the surface, and you could just excavate away at the surface. But for something like Europa, we really are still unclear about how thick the ice layer is, how you would melt through that huge, thick layer to get to the ocean, and then potentially also discussions about contamination. The problem with looking for life in the solar system, which is different from looking for life with exoplanets, is that you always run the risk of, especially if you visit there, of introducing the life yourself, right? It's very difficult to completely exterminate every single microbe and spore on the surface of your rover or the surface of your lander. And so there's always a risk of introducing something. I mean, to some extent, there is continuous exchange of material between these planets naturally on top of that as well. And now we're sort of accelerating that process to some degree. And so if you dig into Europa's surface, which probably is completely pristine, it's very unlikely there has been much exchange with the outside world for its subsurface ocean, you are, for the first time, potentially introducing bacterial spores into that environment that may compete or may introduce spurious signatures for the life you're looking for. And so it's almost an ethical question as to how to proceed with looking for life on those subsurface oceans. And I don't think one we've really have a good resolution for at this point.